Geometry, Semester 1, Final Exam Review. I'll work the first few problems out with you. Number 1. If the measure of angle 1 is 3x plus 36, and the measure of angle 2 is x plus 16, find the measure of each angle. So let me go ahead and label the given information. Now, angle 1 and angle 2 together form a linear pair because they make a straight line when they're composed together. So I know that I should be able to take 3x plus 36 and add it to x plus 16, and my total should be 180 degrees. So now I would need to combine like terms. Combine 3x with x, and you get 4x. 36 and 16, and you'll get 52 is equal to 180. Now, I would subtract 52 from both sides, which would leave me with 4x is equal to 28, or 128. Then divide both sides by 4. So x is equal to 128 divided by 4. Which is 32. So x is equal to 32. And now it wants us to go back and find the measure of each angle. So that means we need to substitute x back in to each one. So the first one would be 3 times 32 plus 36. 3 times 32 is a 96 plus 36 is going to be large, 132, or 132 degrees. And now I need to do the same thing for the second one. X, which is 32 plus 16, and that would give me a 48 degrees. So measure of angle 1, and this is the measure of angle 2. Number 2 says that M is the midpoint of AB, solve for Y. Since M is the midpoint, that means AM has the same measure as MB. So you can set them equal to each other. To solve for Y. First, I would subtract 4y on both sides. Which would leave me with 7 is equal to 5y minus 13. Then I would add 13 to each side. Which would leave me with 20 is equal to 5y. And divide both sides by 5. So 4 equals y. Number 3, triangle. A triangle has its vertices at 2, 5, which is already graphed properly on the grid. Negative 2, 2, which is Q and also graphed properly. And R, which is 4, 2. So I need to put that on the graph. And I probably want to connect the dots to complete my triangle. All right. Alrighty, so it wants us to find the perimeter of the triangle. In order to find the perimeter, you need to know the length of each side. Well, you would have to use the distance formula to do that, or Pythagorean's theorem. So let's use Pythagorean's theorem since that's most recent on our mind. However, you're going to have to use it twice. The distance from Q to R, you just count the units. So 1, 2, 3, 4, 5, 6 units. Now, to find the distance from Q to P, you would form a generic right triangle. I'm going to use a different color. And it has to be right to get from Q to P. And then you would list the sides of the triangle because, again, it's a right. So I went 3 up and 1, 2, 3, 4 right. So I would use 3 squared plus 4 squared is equal to C squared, because this is C. So that's 9 plus 16 equals C squared. 9 plus 16 will give you 25. And then you take the square root of both sides. So 5 is C. So QP equals 5. You do the same methodology to find the distance from Q to R. You would make a right triangle using these tiles. So I went 2 to the right and 3 down. So that means it's 2 squared plus 3 squared equals C squared. So that's 4 plus 9 equals C squared. 4 plus 9 is 13. And you take the square root of both sides. So the square root of 13 is equal to C. Or approximately 3.61. So now to find the perimeter, I need to take 6 plus 5 plus 3.61 and add them all together. 6 and 5 make 11. 11 and 3.61 would give me a 14.61 for my perimeter. Oh, it said round to the nearest tenth, so it's just 14.6. Make sure you read directions. Number 4 wants you to write the inverse of the statement. If a triangle is equilateral, then it is isosceles. So given the original statement is written as if P, then Q. To write the inverse, we would say not P, then not Q. So wherever not is missing, we're going to add it. And if it exists already, we need to delete it. So using the original statement, we're going to say if a triangle isn't or is not equilateral, then it isn't isosceles. Again, I added not next to both of the verbs. And sometimes you might have to introduce a verb to the sentence to be grammatically correct, which is perfectly fine. Number 5, tell if the conjecture is true or false. If false, provide a counterexample. If two lines intersect, then the lines are perpendicular. The conjecture is false because in order to be perpendicular, you would have to intersect and form a right angle. That's the definition of perpendicular. It intersects and forms 4 right angles. But just because a pair of lines intersect doesn't make a 90-degree angle. You could have a pair of lines that intersect and form a 60-degree angle. So as long as you can come up with any other angle measure other than 90, you have a counterexample. A counterexample is just basically an example to prove why it's false. Alrighty, on number 6, they want us to match the pair of angles with the correct name. So let me grab my handy dandy highlighter. Looking at angle 8 and 14 first. When I look at angle 8 and 14, they are on alternative sides, and they're in between 2 lines. So that means they are alternate interior angles. Alright, 1 and 7 are also on alternating sides, but they're both outside the 2 lines. So they're considered exterior, but alternate exterior. (13) and 10 are both interior angles, and they're on the same side. So same side inside means that they are consecutive interior. Same side inside, consecutive interior. And last but not least, 4 and 12 are on the same side of line G, and they're in the same position, both below the top line. So they are corresponding. We're going to take a break right here and come back to resume the review.